to determine the value of R that will give you the maximum power transfer. In short, they are saying find what? R Thevenin. Thevenin resistance, yes. Because according to the theorem, for maximum power transfer, the load resistor should be equal to the Thevenin resistance. So we want to find the Thevenin for this circuit. Oh, we'll start with the resistance. What do we do? Step 1. So from that, you can see which side? Anyway, you follow the transformation, right? So this and this will connect. Hmm. 6. Oh. So when we do the transformation, we'll get something like that. You can redraw it or you can keep it like that. It's okay. So what's the resistance here? 2. So 2, 2, 2, 2. Then next, what do we do next? Hmm? Yeah, we can still do some further simplification. Where? Which one? Mm. Yes, yes. You can be redrawing so that it's easier to follow. So here we have what? Then next, where? This one. Yes. Oh, I didn't put the value. 4. Yeah. Next step. Any next simplification? Hmm? They are in parallel. So they give what? Next. Giving what? Yeah, so now our circuit is simpler. It's now simpler. We can do Thevenin to get the Thevenin resistance. Step number 2 is what? We are finding the Thevenin. So we will remove this and do what to the sources? Independent sources. Mm. Hmm? You switch it off. You switch off the independent sources. You switch them off. In this case, we have a current source. So what do we do to the current source? We open. So now we can look through the terminals. Let's say anyway, the direction doesn't matter. So this circuit has a dependent source. So it's not like the other one we had. Because the other one we just look through the terminals and simplify the resistances until you get one. For this one you can't do that. Can't do that. Because uh the process, the Thevenin's steps, when you follow them, the last part for you to get the resistance, what we actually do, even in a circuit which has only dependent sources like the one we were doing, what we actually do is you put a voltage here, a test voltage. Because what is resistance? Resistance is what? Voltage over current. So what we are doing is we'll set a voltage, let's say 1 volt or 1 amp. Then you find, using the circuit, you get, if I set voltage, I'll get current. If I set current, I'll get voltage. Then divide the two to get. That's what you are doing, even in the other one. But for the other one, you don't state those steps. Why? It has no dependent source. So when you switch off everything, all the sources are eliminated from the circuit. It becomes simpler. So doing that step would just make things complicated. But that's what you are doing. But for this one, it has a dependent source. So you have to do this step. Like you have to do it. In the previous one, it's implied. But in this one, you have to do it. Yeah. So when there's a dependent source, use test and I test, because that's what resistance is. Resistance is voltage over current. Yeah. So set and oh, this is a current source. It depends on the current which is flowing. Yeah. So if you set current, meaning you have to calculate what? Voltage. We have to calculate the voltage which is across there for you to get the RTH. Hmm? Any number. But one is easier to work with. But you can use any number. It's just a test because the ratio it doesn't matter which numbers you use. The ratio will still be the same. You can use 1000 volts. When you calculate, the ratio will still be the same. What we are interested in is the ratio. So, but now we want to make our work easier. Hmm. So we have that circuit. We have to analyze it. Mm, so anyway, from the methods, what can we apply? Hmm? Yeah, you can apply it actually. Mesh, node door. We want to get the voltage across this point. No, it's not. We've These are our terminals of interest. So since there is a dependent source, we've set our current. We've used the current of 1 amp. Hmm? What? Mesh analysis. Yes, we can do that. Any simpler method. This part is not there. It's open. 2 amps and 4 amps. Yes, they are in series. You can combine them. If you want. In fact, that's better. 6. And do you agree that this is I? It's labeled in the question. Current which is flowing here. So I is entering, 2I is entering, and 1 amp is coming out. Can we calculate I? That's the easiest. That's the easiest. That's the easiest method. But we can use the other ones. So maybe let's start with the easiest. So the easiest is KCL. But if you don't see it, you go with the fundamental mesh node. Hmm. So this is I, this is 2I. We can apply KCL. So I plus 2I is equal to 1 amp. This one. So meaning I is what? 1/3 amps. Okay. If I is 1/3, what's the voltage across this point? We've calculated I as 1/3. What's the voltage between these 2 points? Yes, between the 2 points. Hmm? 2 votes. Eh? 2. With yes, between these 2 points. Between the points. Hmm? How did you get 2? The voltage at 6 is 2 votes. Yes, it's 2 votes actually. So the voltage, these 2 points are the same. So you just find the voltage for that. That's the voltage across there. Hmm? For the which one? So that will be what? 2? 2.67. This is 2 times 2i, then times what? Giving you what? So where is 2.67? 2.67 volts. So we want the voltage between which 2 points? If we walk from there, we'll find the what? A source. So this source has some, this is a current source, but you can think of it as there's some voltage. Yeah. So when you move across a source, voltage changes. Although this is a current source, that's just the way of thinking about it. So this 2.67 is just across this point, or from that point to, yeah, not between, yeah. So that's why you can't use this part. You use the other one because for the other one I can walk from. I'll set this as 0. Then I want to reach. So if I start from this point, I'll find the source. I don't know the voltage. So question mark plus 2.67 equal to the voltage that side. But when I move that side, I'll find 2 volts. That's all. Yeah. So it's 2 volts. So RTH is what? V, what's our V test? The voltage we found. The current we set. That's our RTH. Yeah. So when you have a dependent source, this is the procedure. You have to set, you can set a voltage, you can set a voltage. This one. Okay. So we want to get the voltage between these 2 points. The easiest way of getting voltage, you set one terminal. You can set it at 0, or one point of interest. You set it at 0. Then you walk, although it's not walking, but you move from that point, applying KVL. Then you go to the other point. That's what you do. You can do that. Or you can take any point as the 0, then you walk from that point to one node, and from that point to the other node, then you find the difference. You get your voltage. There are various ways of getting the voltage, but the easiest is you set this as 0, then you. So if we start from this point, this is 0 volts. Yeah. You start walking, you find the what? A source. So this source has some voltage. You don't know it. So 0 plus this, as you are walking, this is, let's say this is V. We want to find V, A, B. And this is B, this is A. So you start from B, you have 0 volts. You find the source. So 0 volts plus a source which you don't know, plus you reach this point. When you move across the form, you get what? 2.67. What's VAB? You don't know. Or you can do it the other way. 0, when you move across the resistor, what's the voltage across that resistor? Two volts. So we reach this point. We keep on moving until the point of interest. Do you have a voltage? Do you have a value? Yes. This one we don't. This one we do. So the voltage between those 2 points is what? 2 volts. Yes, that's the VAB. So this is the voltage across those two terminals. Then to get RTH, it's the V test over the I test. So V test we found it to be 2, and our I test we set is the I test we set was what? 1. So 2 divided by 1, 2. You get your 2 ohms as the R Thevenin. The second part was what? Okay. So to get the maximum power, we have to apply the maximum power transfer theorem. And it says when you do your Thevenin, this is the simplified circuit that you get. So the theorem states V Thevenin, or for maximum power transfer, this should be equal to R Thevenin. So you have this value and you have that value. Do you have V Thevenin? V Thevenin? No. So we can't calculate power minus V Thevenin. We have to get V Thevenin. We go back to the circuit and follow the steps for getting the Thevenin voltage. So we can keep our RTH somewhere. So for the RTH, you should go and try. You should go and try setting a 1 volt there and get the current. Then you divide the two to get what the RTH. Because you can do it either way. So you should go and try the other way. Hmm? Yes. You put a voltage source, not a current source. So we go back to our circuit. So before we removed the source, we had simplified the circuit to this. This is how we had simplified it. And we want to get what? Thevenin. How do we get Thevenin? What's the first step? Hmm? We want to get Thevenin. What's the first step? Hmm? Hmm? Yes. So remove the load. This is the first step. Then when you remove the load, you find the voltage across the terminals. That's our VTH. So we walk around which mesh? This point is open. This point is open. It's open. That's the first step when you are getting VTH. You open. So if you want to use mesh analysis, you have to assign a current to this mesh and which other one? Hmm? 3. Where's the other one? You can, but yes. Yeah, can do that. So you have the methods are a lot. KVL, KVL. Where we start from where? This point. Then we go like this. Then yes, it's open here. It's open. There's nothing. So yeah, you can do this. It's okay. So let's do source transformation. So we are adding these two. Yes, they are in series. This part is open, so current will just flow. Mhm. So when we do source transformation, this is 3 amps. So the voltage you get is what? Hmm? 18. So we will have this, right? Then we do what? Which ones? Oh, this and this, because this is what? 6 and 4. We get a 10. Then yeah. Hmm? Hmm. It's 2. Oh, sorry. Mhm. Then we do what? So what are we trying to do? VTH. So when you are finding VTH, what you want to do is to keep those terminals. So whatever simplification you are doing, those terminals should remain. You get? Those terminals should remain. So in this case, we've simplified the circuit, yes, but we've lost terminals. So you always have to keep those terminals. Yeah, you can use mesh analysis, or but there is a faster way of doing this one. This part is open. So how is it flowing? It's entering this node, then 3 amps is coming out. We can find the I. Remember we found I in the when finding RTH. This current, this part is open. So current is flowing like, it's not going that side, it's open. So it's flowing like this. So this, the current which is entering this point is I. What? I is equal to 1. Yes. Mhm. So we can find I. This is the fastest way, but you can use mesh analysis, you can use node analysis. Yeah. We can apply KCL. And what current is entering this point? So I plus 2I. Current entering is equal to current coming out. Therefore, I is 1 amp. Mhm. So we have I, but we want to find VTH. Does it help us in getting VTH? Hmm? Does it? Or maybe we didn't even we didn't even discuss what strategy are we using to get VTH. We didn't. Hmm? Okay. So we have a current flowing through this 2 ohm and we have the resistance. So what's the voltage across this 2 ohm resistance? 2 volts. So the current is going like this. It's going like this. So the voltage is in the other direction, 2 volts. So between these 2 points, there is 2 volts. And we want to find the voltage between. So is this equal to that? That's the question. Through 4 ohms. What? So yes. What's the current which is flowing through the 4 ohms? Hmm? Hmm? The current which is flowing here. What's the value? Hmm? It is what? 2I. 2I. Why? Hmm? So this part is open. There's no current which is flowing. Maybe we do this. So this is 2I. You're correct. So 2I. I is 1. So it's 2 amps in short. And it's flowing like. So the voltage is going in which direction? So what's the voltage? This voltage. We have current and we have resistance. So having these values, can we get VTH? Hmm? We want the voltage between these 2 points. So when getting voltage, first strategies. Do you know the voltage which is? You can set some point where you are measuring from. Then measure the voltage which is there and which is there. Then you do what? You find the difference. That's the first strategy. Or yes, do we have current which is? Do we have the value of current flowing through the forms? Hmm? 2I. What is I? 1. So what is the voltage across the 4 ohms resistance? Okay. So I think the first strategy when finding voltage across the terminals which are open is you start from this point. If this is 0 volts, I have to walk from this point to, and then that's VTH. Yeah, that's applying KVL. The voltage along, you are walking along a loop. So that's how we can get VTH. We start from this point. We assume it's 0 volts. You can assume any value. Because if I assume, let's say it's 5 volts, I'll walk, then I'll find the voltage which is, then I find the difference. But if I assume this as 0, there's no need to find the difference because it will be whatever value minus 0, which is just that value. You can set it as any value. It's up to you. Yeah. So we start from this point. Now, working from this point and reaching this point, what is the voltage, VTH? Hmm? So what? No idea. Okay, let's work. If they are in, mm, subtract. Mm-hmm. Mm-hmm. You get, yeah. So that's correct. But the best way of doing that is you walk. Mm-hmm. But it's not like you are. Uh, let's say if this was like this, then you do what? You add. So you're just adding or subtracting. But walking will show you will give you the actual direction of this voltage. Yeah. Without you making assumptions. So you start, it's like this. Minus, plus. You start at 0. You have 0 volts. Then this voltage, this is a voltage rise. You are moving from a negative terminal to a positive terminal. So 0. When you move from negative to positive, what do? You gain in voltage. So you add 8 volts. Then you reach this point and you turn. You meet a positive terminal first, then a negative terminal. So when you move from positive to negative terminal, you do what? Subtract. Voltage drops. And your final value is what? 6 volts. So meaning we've moved from this point to the other point. So what's the voltage difference? We assumed this as what? 0. So it's 6 minus 0. You get 6. So when you assume this as 0, just walk around the loop, you get your voltage. You can assume it as 5. When you do that, you find the difference, you still get 6. Oh. So VTH is 4 times 2i plus or minus 2 times I. So this gave us 8 minus 2, which is 6 volts. We found the VTH, we have RTH. We can now go back to the simplified circuit to find the maximum power. Okay. I can rub.